Yo, what's good? So got another video just doing questions. My bad. I'm not sure if that was loud for you, but yeah. So going kind of a little bit backwards now. Just going over solutions for chemical equilibrium because I finished off the acid-base practice. So I guess I'll just go back to this one because I didn't fully understand the next topic yet, and I don't really want to go into that yet. But yeah, so this is like something I learned some time ago. So I guess this might be a bit more easier because I have a better understanding of it. But yeah, we'll just get started. I'm just yapping now. So we got a substance that forms readily from carbon monoxide and chlorine at higher temperatures. So we have the reaction there. And then we have the K value, which is 1.2 times 10 to the 3. So immediately we could assume that this is this is a large K reaction. The forward reaction is large K. So now we're asked what the moles of Cl2 will be at equilibrium. So first step here is just to kind of make an ice table really quick. So we'll just draw out the reaction. CO, but this pen is so dumb. CO plus Cl2 form COCl2 gas. K equals 1.2 times 10 to the 3. And I'll just write this as large just so I remember it. So now we'll just make an ice table. Initial change in equilibrium. That reminds me, I need to start working on a chem pre-lab. But anyways, so CO starts initially with 0.35 moles, but we want to do this in moles per liter. That's the unit. So quickly just doing that calculation, maybe down here. That is just equal to the number of moles, so 0.35 moles divided by 3.05. And you should get 0.00180. That's CO, right? CO 0.35 divided by 3.05. Actually, no, this is wrong. She get 0.115. Okay, so next one, COCl2. That's just equal to 0.055 divided by 3.05 liters. And you'd get 0.018 moles. So we can fill that in here. So they don't explicitly mention how much Cl2 is in the flask initially, so we'll just assume that is 0. So now if there's no reactant, that means the reaction must be proceeding in the reverse. So yeah, so this K value here, 1.2 times 10 to the 3, this is for the forward reaction. So we need to find what it is for the reverse reaction. And if you recall, the K reverse is simply just equal to K to the negative 1 of the forward. So here we are, we got 1.2 times 10 to the 3, all to the power of negative 1. And that's equal to 8.3 times 10 to the 10 to the negative 4. So this is K reverse. I feel like I'm writing a bit too big right now. Let me just shrink everything. Low-key, maybe this is a bit pointless, but I don't know. Okay, I'll write a bit smaller. Okay, so here we are. We got the K reverse. I'm looking going all over the place, but if we know that this reaction is happening in reverse, that means the reactants must be getting plus X, and minus X. So therefore, the equilibrium concentration will be 0.115 plus X, and 0.018 minus X. So now, if we know that this is what we're at equilibrium, we could just substitute this into like the K, what do you call it, like the K ratio, I don't know how you call it, the equilibrium constant. So we got products, which in this case is 0.115 plus x and x, which we'll write on the top. So over the reactants, which is 0.018 minus x, and that would be equal to the K reverse. So that's 8.3 times 10 to the negative 4. So now this is a small k, right? So therefore we can make the assumption that 0.115 plus x is just equal to 0.115, and then 0.018 minus x is just 0.018. So now if we write that down here, we get 0.115 multiplied by x over 0.018, and that will just be equal to 8.3 times 10 to the negative 4. So 0.115x is going to be equal to, what would it be? I pre-entered these into my calculator, but now I can't like find the right value, bro. It would be 1.50 multiplied by 10 to the negative 5, and then x would just be equal to 1.31 multiplied by 10 to the negative 4. So this is our x value here. We're almost done, but we need to first make sure, because we made those assumptions here, we need to check those assumptions with the 5% rule. So we'll just do that down here. So in order to for this assumption to hold true, what we did here, we just have to take the x value and divide it by what we added to or subtracted it from. So we'll just do that right now. So we got our x value, which is 1.31 times 10 to the negative 4. Then we just divide that by 0.115, which is what we added down here. And then multiply by 100 and see if it's greater than 5%. Here, what we'll get is just 0.73%. Clearly, this is less than 5%, so therefore we're all good with this one. The second one we need to do is just 1.31, because that's our x value, so it's the same one, and divide that by 0.018 multiplied by 100 equals 0.11%. So it also holds true here. So the assumptions are right, and this is what our x value will be. Now the question is asking how many moles of Cl2 will be present at equilibrium. So first, something to note is that it's asking for moles, not moles per liter. So we got to find that out. So if we know that x is equal to 1.31 times 10 to the negative 4 moles, we could just use the C equals N over V. So N equals C times V. So we got the concentration, which is 1.31 times 10 to the negative 4. And then our volume of 3.05. And once we multiply those two, we should get an ending value of 3.99 times 10 to the negative 4 moles of Cl2. And that's our answer. So honestly, this was honestly pretty easy, I can't lie. Now that I understand acid-base more, this makes more sense to me. So yeah, that's question 1, and I guess we'll just move on to question 2 now. Okay, so here's question 2. This is kind of similar to a question that I earlier, I remember, with the volumes and stuff like that and pressure. So I guess we'll just get started with this one. First step is just to kind of write ice table. It'll just make things much more easier. So 3H2 gas plus P2 gas, 2PH3 gas. Also, wait, one more thing about this one. So this is a large K reaction and it's going in the reverse direction. So I remember something I said in the previous video is like, yo, it'll push past the equilibrium point and then it'll go somewhat in reverse. So I thought initially that when I did this question is that it would go in reverse past the equilibrium. It would go past and then we would go forward for a bit. But apparently that's wrong. Apparently you can't do that. And I didn't know that. So I asked ChatGPT about it. And it was saying something like, yo, it only does that if it's in the forward reaction first and then it'll go backwards. So we kind of have to assume that this reaction is, it's like already had the large K reaction and now we're just going like with the kind of small K reaction backwards. So honestly, I'm not really sure what that means. So I'm probably gonna go to my prof's office hours just to make sure. But yeah, I'm okay lost on that. I just wanted to point that out. Anyway, so continuing on with this, just making the ice table. Initial change in equilibrium. So here we are, 1 atm of H2. So this is units atm. So here 1.00, 1.00. Okay, so at equilibrium would just be 1 minus 3x, 1 minus x, and 2x. So now we could make the, what is it? Wait, do we even need to do that? No, I don't think so, because, so it says the total pressure of the vessel was 1.91, and that's like our equilibrium. So they should all equal 1.91 atm. So I think this is like, I think that's just simple like math now. It's just 1 minus 3x plus 1 minus x plus 2x is equal to 1.91. Wait, why am I looking? Negative 2x is equal to 2 plus 2. 1 plus 1 is 2. 1.91 minus 2 is okay. Negative 0.09 atm. Therefore, dividing both sides by negative 2, I'm pretty sure you understand how to do that. Should get 0.045. That is what our x value is equal to. Now it's asking calculate the equilibrium constant. So that's what we need to do now. K is equal to the products. So this reaction is happening forward. So product is just 2x squared. Remember the coefficient. And then divided by 1 minus 3x to the power of 3. And 1 minus x. And we just substitute that in. That's low-key a lot of work. Multiplied by 2 square 0.0081. 1 minus 0.045 times 3 to the power of 3. 0.65. And then 1 minus 0.045 should be 0.96. And yeah, if you divide that, we should get a final answer of 0.013. Honestly, I'm not really sure if I made an error. I'm just looking over my calculator notes. Maybe I wrote something wrong, but this would be the final answer. And hooray, you did it. So yeah, that's pretty much it for today. Pretty simple day, but yeah, just going through the motions of it, bro. School low-key sucks, bro. Today was a long day. Not really enjoying school, but I guess that's life. So yeah, that's pretty much it for today, and I'll see you in the next one.